In this video, we'll finish up our discussion over section 4.6 variation parameters. We've been doing second order, higher second order diffie-qs, linear diffie-qs. Now we're going to do higher order ones. How this changes is our Wronskian gets bigger. That's all it is. So if I have three solutions, I'm going to have a 3x3 Wronskian the whole time, right? So here they extended onto into n, right? And then they in solutions, and then an n by n matrix, and then we just keep going with our w's, and we do that same thing. The only thing that's going to be terrible is now that our Wronskians are 3x3, so they're going to take a little bit more work. All right, let's do an example. Okay, first things first. So there's my diffie-q. It's a non-homogeneous case, so I need to start with my homogeneous case. So homogeneous, I'm going to have y triple prime plus 4y prime, and I'm wanting to solve it when it is 0. So this is m cubed plus 4m, right? If I factor out an m, okay, I'm going to get m equals 0 and plus or minus 2i. All right, so that tells me my complementary solution is c1 e to the 0x plus, and then it's going to be e to the 0x times c2 cosine 2x plus c3 sine 2x. I'm definitely going to simplify that. I got c to the c1 plus c2 cosine 2x plus c3 sine of 2x. All right, I'm going to shrink that up for room just because I'm going to need it. So I have that as my complementary solution to the homogeneous case. All right, now we're going to do the particular case. So we need y1. So y1 is going to be 1. That's kind of tricky there. Y2 is going to be cosine 2x. And then y3 is sine of 2x. Now I'm going to need the derivatives going down. I think we should just go ahead and go to the Wronskian. So the Wronskian of those three, right? I get a nice pretty 1, 0, 0. Okay, and then I get a cosine 2x, and then a negative 2 sine 2x, and then a negative 4 cosine 2x. Right, and then sine 2x is going to go in the same manner. I get a 2 cosine, let me rewrite that. A 2 cosine 2x, and then a negative 4 sine 2x. All right. So I'm going to go down. There's several ways we can do this. We do have to follow a rule here, whichever row or something you want to go down. I'll explain what I mean by this. We need to have this in mind. When we did our cross products in Calc 3, if you've had that in the previous Wronskians, we would do something like this, and then we would like move, you can move the row, you could also take it and move the column 3 times, but you just, whatever you're moving, be consistent. I'm gonna go down my rows, and I'll show you why. So, okay, the first one, I'm gonna get whatever is left after I crossed out my rows, so I get negative 2 sine 2x, 2 cosine 2x, and then negative 4 cosine 2x, and then negative 4 sine 2x. This is times the intersection. So I get times 1. Now, I'm going to go down with my row. That means now when I finish it out, I got to go down again. I can't change the column now. I got to change the row again. So notice that the intersection here is a minus. That tells me to put a minus out front. All right, so I get that minus, and then I'm going to write down what's left if I mark those out. Okay, I get cosine 2x, sine 2x, and then the bottom, I get negative 4 cosine 2x and negative 4 sine 2x. But it doesn't even matter what's on the inside here because the intersection is a 0, right? Do you see that if I move my row 1 last time, I'm going to have a plus, and then I'm going to have something that's left here, right? And I'm not even going to write that down for a moment. Something inside there, but the intersection again is a 0. So that's where these zeros are coming from, is this 1 is here, and that was this case, right? Right? This 0 is here, and that was this case. And then the last case, this 0 is here at the intersection. So I don't even care what goes inside of here because it's times by 0. So the only matrix determinant is going to value anything will be that first one. So I'm going to write that 8 times sine squared of 2x plus, because it's a minus negative, 8 cosine squared of 2x. Now, I do have my identity. I would just factor an 8 out, and that's what I would get. So W is 8, right? We got to do W1. Okay, W1, I'm going to replace the first column with 0, 0, and then the function, secant 2x. And then everything else is the same. So I'm just going to duplicate. Okay, so if everything else is the same, you can see that the 0 thing works here as well. The only one that's going to work out will be this and that if I take down that same route. So I'm going to write down what's left inside of here. I guess I could have copied and pasted again, but oh well. And this is going to be times a secant 2x. You can see that any other multiplication, if I just move my row down, is going to be times a 0. So I'm not even going to think about it. I'm just going to leave it like that. All right, so this gets me 2 cosine squared 2x plus 2 sine squared 2x times secant 2x. So the identity works here. I get 2 secant squared, or secant 2x. All right, so we got to do W2 now. W2 is going to have a lot of zeros, 1, 0, 0, and then 0, 0 secant 2x, and then I just keep the third column the same. So I kept the first and third column the same. Okay, notice now the same argument can be made, but the only one that's going to stick around if I move the row down each time, because the intersection is 0, this is the only one that's going to work out. So what's left here is 0 secant 2x, 2 cosine 2x, and negative 4 sine 2x. And then this is going to be times a 1, because that's my intersection. All right, I get a 0, and then minus, and cosine times secant is a 1, so it's going to be just a negative 2. All right, we got one more to do. W3. Okay, I keep it 1, 0, 0. Keep the middle column. So we're keeping the first and middle. And then I'm going to replace the last with 0, 0 secant 2x. Right? Again, the same argument can be made. I could just move the row down each time. That's the only thing that's going to catch. So I'm going to do negative 2 sine 2x, negative 4 cosine 2x, and then 0 secant 2x. Right? If I multiply that, secant's just 1 over cosine. I'm going to get a negative 2 tangent 2x. All right. So now we can find our solutions. It's going to take some integration. I know that u1 prime is w1 over w. W1 was 2 secant 2x over w, and w I think was a nice pretty 8. All right, so that gets me u1 to be the integral of 1/4 secant 2x. I believe we already did a secant 2x or secant x today, so I'm just going to jump to the formula. We get a The 2 is going to produce a 1/2, so I got to get a 1/8 ln, and then secant 2x plus tangent 2x. This is using the same rule that we did in the same section. If you need want to do it by hand, please go back and look. Okay, u2 prime will be w2 over w. So that's negative 2 over 8, which is a negative 1/4. That means u2 is negative 1/4 x. All right, it's an easy one. U3 prime will be u3 over w. So that's going to be a negative 2 tangent 2x over 8. That's a negative 1/4 tangent 2x. All right, so u3 then will be the integral, negative 1/4 of the integral of tangent 2x dx. All right, this is another, we've done it today. You do sine over cosine, do a u sub at the bottom, and it will introduce a half as well. So this is going to give us a negative 1/8 ln of cosine of 2x. All right, so I have all the u's now. So my particular solution is going to be 1/8 ln of secant 2x plus tangent 2x. And that's times the first one, which was just 1, okay? And then minus 1/4 x times the second, which I think was just a cosine 2x. And then the last thing, it's going to be minus 1/8 ln of cosine 2x times sine of 2x. Let me go make sure that those were our solutions to begin with. They were. Okay, so that's y sub p. Okay, so y sub c then, or not, we have y sub c. Y, general y is going to be c1 plus c2 cosine 2x plus c3 sine 2x, and then plus what we just found. All of this duplicated, shrank way down, and put right there. So there is our overall solution to that diffie-q. This has been checked, so I know that one's for sure. The couple integrations that I skipped here, I encourage you to go learn to do them by hand. They're not too difficult. You just got to get used to being able to identify it. All right, that's it for this section. I think any more examples, it's going to be a little drony. So give that a shot, work through them, go slow. Make sure your handwriting is very neat so that way you don't make a mistake based on missing a prime or anything like that. Give yourself grace. These take a while to get good at.